Sorry, I forgot to start the recording. Been a while. I'm out of practice. Okay. So in a system of linear equations, two lines with different slopes. When I see the line different slopes, I know what I have. I have two lines across each other. This is a consistent system. Because I have an answer. They will cross each other at some place. Now, if I have the same slope, then I look at the y-intercept. Same slope, same y-intercept, it's consistent. Same slope, different intercepts, they're parallel, it's inconsistent. Okay, but if I see different slopes, I'm done with that question. Okay. Okay, so this one here, you have to graph the two lines. Where do they cross? So the first one, my y-intercept is -2. My slope is 3, so I go over 1 and up 3. I graph the second line. This one's a little more difficult. I could put in mx plus b form, but that's not really going to help a whole lot. So what I'm looking for is, if I have my y-intercept is 5/3, which is 1 2/3, so 1 and a little bit more, bless you. My x-intercept is 5/2, which is 2 1/2, so that's here. And it's going to go through. Now, I will tell you on a test that I give you, those lines will cross at a coordinate that are integers. There will be no fractional or decimal parts to a coordinate on a test that I give you. Okay, so although this one is not perfect, I look at that and I'm going, okay, that's the 0.11. Because even if you're not perfect on your graphing, that's close to where it will be. That's good enough. You know it's going to be at an intersection of the grids. It's going to be two integer ones. You're not going to have fractional points. You're not going to have decimal points to worry about. Okay, so if you get that on the test, you might want to go back and look at your graph. Maybe give it a little bit better shot. Use one of my rulers. Look at the line again. Did I graph it correctly? Take the time to go back and look at it if you don't get integers on it. Okay? Solve the system using substitution. Remember, if it says substitution, you must use substitution. I will need to see evidence, either on the test or on a separate sheet of paper. If you do it on a separate sheet of paper, label it question number 3. If this is on a separate sheet of paper, put 3 and show your work. I need to see work on this one. Answers, no work, no credit. Okay, I want to be perfectly clear. Answers, no work, means no credit. I have to see that you used the directions. Okay, you don't follow the directions on this one, and on the next one, it doesn't count. So, y is -3x plus 4. So 2x plus 3 times -3x plus 4 equals -9. You solve that to find your x. 2x minus 9x, minus 9x plus 12 equals -9. -7x equals -21. Divide by -7. X equals -3. Sorry, positive 3. So x equals 3. And then I got to find y, so I take 3, plug it in for x. 2 times 3 plus 3y equals -9. 6 plus 3y equals -9. Subtract 3y plus 3y equals -15. Divide by 3y equals -5. Okay. You must follow the instructions. That's probably the worst thing that kids do. It is not follow the instructions. And some of you found out on your quiz, when I graded the quiz for 3-2 that had this on there, if the work was not clear that you used substitution when you were supposed to use substitution, if I couldn't see evidence of that, got a 0. Okay, even if you may have, but you weren't clear enough in your work, and there were some people whose work was extremely incomplete and did not show, I could not see a substitution actually taking place in the problem. I can't give credit for substitution if I can't tell what you did to solve it. Okay, and I've seen some pretty sloppy work. Been teaching for 20 years. My handwriting's not bad, but I've got kids who've been a whole lot worse than mine. Okay, and I've got some work that I've seen that's really sloppy, and usually I can figure out what's going on. Extremely rare that it's so bad I can't figure out what's going on. Extremely rare. I think we had maybe once or twice. Okay, and then I'll ask the kid, what are you doing here? Okay, so I need to see it. I can pick it out, believe me. You guys, if you'll saw each other's tests, you're like going, how does he grade this crap? Okay? Some people, on the other hand, are nice and perfect and use multiple colors and all that stuff. I've had ones that are like, oh, this is a dream test. I wish I just want it. I'd like to give extra credit because it's so neat and pretty. But I don't, because it's got to be right. Okay, solve the system using elimination. You must use elimination if I say use elimination. Okay, when I do elimination, I have 4 steps. First thing is, can I eliminate by addition? Will something go away by adding it by itself? No. Can I eliminate by just doing subtraction only? No. So I have to multiply. Can I multiply just 1? I can't make 3x look like 4x without using fractions, and vice versa. I can't make 2y look like 3y without using fractions. So multiplying 1 isn't going to work. So I'm going to have to multiply 2 equations. Now, I look at this one, I would eliminate y. If you do x, that's okay if you did x first, but I would do y because one's positive and one's negative already. Multiply the top equation by 2 and the bottom equation by 3. So I do the bottom one equation by 3 and I get 9x minus 6y equals 30. Top one by 2 and I get 8x plus 6y equals 8, or sorry, equals 4. 2 times 2 is 4, not 8. Come on, 2 times 2 is 4. And now, because I have 2 that are exactly opposite, I can add the equations. 9 plus 8 is 17x equals 34. Divide by 17, and x equals 2. I still have to find y, so I plugged it into either equation to figure out what y is. Do the top one because my y's are positive. 4 times 2 plus 3y equals 2. 8 plus 3y equals 2. 3y equals negative 6. Subtract 8 from both sides. Divide by 3. And y equals negative 2. Okay? Must use elimination if I ask for elimination. If I see substitution on this, it'll give it to me. It's rare that I see substitution on this, but I actually have seen students do substitution instead of elimination. It doesn't happen very often because everybody loves elimination and hates substitution. But people tend to be better at substitution than they are at elimination. On the quiz, a lot more mistakes on the elimination problem than there were on the substitution problem. But nobody likes to do substitution, but they generally do better at it. Go figure. Okay, next one. You do not actually have to solve this. It does not say solve. It says set up a system of equations. You're not actually solving the equations. Okay, so I have 2 equations. One for how many and one for how much. So all 42 athletes on the ski sport/board team went on a one-day trip. Members could rent skis for $25 a day, snowboards for $19 a day. The club paid $888 for equipment. Set up a system equation. So you have one for how many skis and snowboards they rented. Okay. I kind of don't like, I didn't make up this problem. I kind of don't like it because I have snowboards and skis. They both start with the same letter, so it makes for a crappy equation. But realistically, x plus y equals 42. Because I got 42 kids on the team. X number rented skis, X number rented snowboards, or vice versa. It doesn't really matter at this point. If I were solving it, it would matter more. Okay. Then I got price for one, price for the other, and how much they spent. 25x plus 19y equals 888. And that's it. One for how many, one for how much. That's it. Okay. That's it. Now, I hope they kept better receipts and didn't have to figure it out the hard way like this. I always laugh at these problems. Susie sells peanuts and cashews. Charges so much a pound for this and so much a pound for that. She sold 50-odd some pounds and got so much money. How many of each did you sell? My first thought is Susie's going out of business. She can't keep better records than that. And it has to use algebra to figure out how much she sold. Okay? That's just bad business. All right. It is. Solve the system by graphing and shading. This is what I just handed back. So the first one, y is greater than or equal to -1. So I have a solid line on -1. And I want everything larger than that. My second graph, 3x minus 2y is greater than or equal to 6. So let x be 0. My y-intercept is -3. 1, 2, 3. Let y be 0. My x-intercept is 2. Yes? You're right, I did. Oh, my Lord. I'm screwed. Ignore all that. And you got it on tape, too. Evidence that I'm not perfect. Oh, well. Thank you very much. -1. Everywhere above. My bad. My bad. Thank you for catching that. Thank you. Seriously. So we have that one. That's y is greater than or equal to -1. So I figured out my y-intercept was -3. My x-intercept was 2. It is greater than or equal to, so it is supposed to be a solid line. I have to test. 0 minus 0 is less than or equal to 6. 0 is less than 6. So it's everywhere above. Where's my solution? This is my solution area. So when you take your test, I recommend that you have a highlighter with you, colored pens or pencils. Makes it neater, makes it easier for you to see what you're doing as well. Okay, it makes it easier on you to see what you're doing if you have those. Makes it easier for me to see what your solutions are. Okay, it just helps. It helps you, it helps me. If you don't, it's not the end of the world. Okay? Same thing on the next one. I graphed the first one. My y-intercept is -1. My slope is -3/4 over 4 down 3 over 4 down 1, 2, 3. And it is a solid line on this one. I test the origin. 0 less than or equal to 0 minus 1. Yes, 0 is less than 0 minus 1. So it's that. Okay. Now the absolute value one. It's a V. Remove the vertex. The +2 means that I go to the left 2. Remember, inside, opposite, right and left. So I go left 2. The -2 means that I go down 2. So it goes over 2 and down 2. And this one's a dashed line. And this one actually does go through the origin. So I can't use the origin as a test point. Okay, I can't use the origin as a test point. So what do? I pick some other point. Now, pick one that is obviously inside or outside. You can use something higher up or lower down on the X or Y axis. Here's what I like to do to make sure I have something directly on the inside or outside. Take the vertex and move either up or down from that. So then it doesn't matter if I screwed up how wide or narrow it was. If I go straight up or straight down from the vertex, I know I'm either in between or I'm outside. I don't have to worry about if I got the width correct on the absolute value if I go directly up or down from the vertex. I know that any point straight up is inside, or any point straight down from the vertex is outside. So I pick one straight up. That would be the -2, 0. -2 for x, 0 for y. -2 plus 2 is 0. 0 minus 2 is -2. 0 is greater than -2. So that means that everything inside is part of it. So I have that line there is an edge, that line there is an edge, and it's everything inside. Okay. We good so far? Okay, which set of coordinates below minimize the objective function p equals 4x minus 2y? How many vertices do I have to worry about? One of them is not labeled. Which one's not labeled? 0, 0, the origin. This one's not labeled, but this is a vertice. This is where they meet. They meet there. They also meet at 0, 0. So I have to include that as part of my possible answer. Okay. So what do? I have to test all 4 points and say which one of the 4 gives me a minimum. Read the question carefully because I might ask for maximum on the test. I might ask for minimum on the test. You must read the question carefully, know which one I'm asking for. But you have to test them all. So P 0, 0 is 4 times 0 minus 2 times 0, which is 0. Not guaranteed that that's the minimum. I'll move up, 0, 8. P 0, 8. 4 times 0 minus 2 times 8 is -16. My most likely candidate, but I got to make sure. P 5, 4. 4 times 5 minus 2 times 4 is 20 minus 8, which is 12. And then last but not least, P 9, 0. 4 times 9 minus 2 times 0 is 36. My minimum is -16. What does the question ask me? What is the question asking me to find? No, it's not asking me for the minimum. It's asking me where the minimum happens. -16 would be an incorrect answer. Your correct answer would be 0, 8 because that's where it happens. Read the question carefully. There's a difference between where it happens and what it is. Where is the coordinate -16 is what the minimum value is. Question does not ask me the minimum. It says where does it happen? So where does the minimum happen? It doesn't ask for the minimum. It says where does it happen? If you put -16 in there, you got it wrong. Okay? Read the questions carefully. It's the most common screw up is not reading the questions carefully to begin with. Okay? All right, here we go. So, same idea, but this one you actually have to do all the graphing too. Okay, you don't get the graphs already. You have to do the graphing. And then on this one, find the maximum and the coordinates where it happens. So first thing is I graph them between 0 and 5. 5 on the x and on the x-axis, and it's everywhere inside those two lines. The next one is y is between 0 and 8. 0 and 8. And it's everywhere inside. And currently I have this nice little rectangle, but it's not going to be that easy. I have to do the x and y intercepts. 6 and 6. And I want everything less than that. So if I put in the origin, because I can test it, 0 plus 0 less than or equal to 6. Yeah, 0 less than 0, so it's everywhere down here. So my area is this quadrilateral. 4 sides, right? Quadrilateral, 4 sides. Okay. So I have the origin as one of my vertices. The point 0, 6 is one of my vertices. The point 5, 0 is one of my vertices. And then this one goes up. This is the point 5, 1. That's my other vertice, 5, 1. I got 4 of them. Now I have to test them one at a time, see which one's which. So, P 0, 0 is 5 times 0 minus 9 times 0, which is 0. P 0, 6 is 5 times 0 minus 9 times 6, which is negative 54. And then I have P 5, 1, which is 5 times 5 minus 9 times 1, which is 25 minus 9 is 16. And then I have the point P 5, 0, which is 5 times 5 minus 9 times 0, which is 25. Have to test them all one at a time. Plug in the coordinates for x and y, test them one at a time. It is asking for the maximum and where the maximum happens. My maximum value in this case is 25. And it happens at the point 5, 0. Once again, read the question carefully. On the test, it might ask for what's the minimum. Read it carefully. And remember, there's a difference between the maximum and where it happens. If it asks for where, you give me where. If it asks me for what, you give me what. There is a difference between the two. Okay? Questions? All right. Going to limber up for this one. Solving a system of equations. Solving a 3x3. First thing you do is eliminate one of the variables twice, taking it down to a 2x2. You can do any one you want. I look at this problem and go, man, easy peasy, get rid of the x. That's the easy one to do because I have one of my x's is already negative. So if I have to do any multiplying, it's easy multiplying to take care of that. So first thing I'm going to do is I'm going to add these two equations together. So I get x plus y plus 2z equals 3, negative x minus 2y plus z equals 10, and I add them. X and negative x cancel. Y plus negative 2y gives me negative 1y. 2z plus z gives me 3z. And 3 plus 10 is 13. There's one two-variable equation. Now I need to find another two-variable equation. Once again, eliminating x, which means I have to use the middle one and one of the other two. Because eliminating y or eliminating z at this point doesn't help. I need two equations with the same two variables or I can't do it. So I'm going to take the middle one and 2 times the bottom one. So 2 times the bottom one gives me negative 2x minus 4y plus 2z equals 20. And then put the middle one in, 2x plus y plus 3z equals 7. Add them together, negative 3y plus 5z equals 27. And those are my two equations. Actually, this was the sample problem I did yesterday, wasn't it? Good to see it again anyways. Okay. So now I've taken it down to 2 equations and 2 variables. That's my new system. Okay. Negative y plus 3z equals 13. Negative 3y plus 5z equals 27. Ooh, no, it's not the same one. Okay. So now I have to eliminate y or z. Eliminating y is actually very easy on this one. Multiply the top equation by negative 3 in this case. Normally I don't like to multiply by negatives. Multiply by negative 3. And I get 3y minus 9z. Ooh, it is the same. Equals negative 39. Bottom one, do not change. I get negative 3y plus 5z equals 27. Add them together. Negative 4z equals negative 12. Divide by negative 4. And z equals 3. So there's one of my answers. Z equals 3. Still got to find x and y. Take that 3, plug it into any equation. I would put it into this one here. Negative y plus 3 times 3 equals 13. 3 times 3 is 9. And negative y plus 9 equals 13. Subtract 9. And negative y equals 4. So y equals negative 4. Take those two, plug them into any of the equations to find x. I would put them in the top one just because x is positive all by itself. So x plus negative 4 plus 2 times 3 equals 3. X plus 2 equals 3, so x equals 1. Like I said, this is your biggest single question on the test for points. The previous one we did where you were graphing and finding everything, that's another one that's worth a lot of points all by itself as well. Okay. It's tough having one that's worth a lot of points like this, but there's a lot of stuff going on too. Okay. Questions on this? Okay. Last but not least, your performance task. Okay. 3 friends, Kelly, Chris, and Sam, are delivering flyers in Placerville neighborhoods to promote their lawn care business. Working together, they can deliver 295 flyers every hour. Kelly and Chris can deliver 186 flyers per hour. Kelly and Sam can deliver 194 flyers per hour. Using K to represent the number of flyers Kelly can deliver, C for Sam, Chris, and S for Sam. Answer the questions below. 1. Write an equation for the total number of flyers. Working together, they can deliver 295 flyers per hour. Kelly plus Chris plus Sam can do 295. Easy. You're told the 3 variables to use, KS and KC and S, and how much can they do together. Second one, write the equation modeling the number of flyers Kelly and Chris. Kelly plus Chris. Let's see. Kelly and Chris can deliver 186 equals 186. Question number 3. Kelly and Sam. Kelly and Sam. Kelly and Sam can deliver 194. Kelly plus Sam is 194. How many flyers can each deliver? In other words, solve the system. Those are my 3 equations. solve my system of equations. Now this one's actually an easy one to do. This is actually a very easy one to do. K plus C plus S equals 295. K plus C equals 186. Subtract, and Sam can do, oh, I gotta do this, I can't do it in my head. I think it's one something. 295 minus 186, 109. Sam can do 109. 109. 109. Now here's what's really cool. I can do this again, but I don't need to. Because I can go up to this one. Kelly and Sam can do 194. That means K plus 109 is 194. Subtract 109 from 194. And I get Kelly can do 85. Okay. And then I don't need to go back to the original one to substitute those two in to find Chris. I can just go to this one here. Kelly plus Chris can do 186. 85 for Kelly plus Chris can do 186. So Chris can do 101. I can do that one in my head. Subtract 85 from those sides. So Chris can do 101. Piece of cake, easy peasy. Write the equations, take your time, and then solve them. Take your time. Do the arithmetic, solve the equation. This one will be an easy one to solve the system. It's not like some of the other ones are. And don't make assumptions about numbers. I had kids that all just take 295 and then divide it by 3 and that's my answer. No, it's not. They obviously do not work at the same pace unless this number and that number were the same. That'd be the only way that they would be working at the same pace. And this is 3 times what this is 2 times. Divide this by 2, take that times 3, you'd get that one, and they all do work at the same pace. They don't. Do not assume that. I have students every year. They're either not paying attention